Hi, I'm David and welcome to Leisure Bit, and today we're covering the summary of the Lithium series where we show you how it's connected up, so let's get on with it. So, as you'll know if you've watched the series, if you haven't, there's links below to the playlist for the rest of the series, and I appreciate not everybody wants to do something exactly the same as I've done. You might be just looking at it to get an idea of what might be involved with it, and as I've said all the way through the series, if you don't feel confident and competent with electrics, get somebody who is to give you a hand with it. So let's have a look through then. So firstly, just a reminder of the different things that I've installed in the van. So obviously the lithium battery, and we'll come on to at the end. I've done a little bit of a review of what the costs looks like for it. I've got a follow-on video. This one kind of focuses on how it's connected up, just to bring that together a little bit. So let's just do a quick recap of where we've got to, and then we'll start going through tying it all together. So we started with an introduction to the lithium battery. I'll pop a link in the video as we go through to each one of these if you want to go and watch the video, or if you want to re-watch the video and then follow the links, or you can pick it up from the playlist which is in the description below. Anyway, so we started with the lithium battery introduction. We then moved on to upgrading the solar controller, and we upgraded to one which had MPPT to get the most out of the available solar energy we got, and it was lithium compatible. Then we started the work to prep for lithium, so essentially we removed the old battery and just got the cage and the case and everything cleared for that one, ready to install a lithium battery. We then moved on and installed the keeping the vehicle battery topped up with a battery maintainer, which has come in really handy. Ever since I've installed that, the start-stop started working pretty much when it needs to now. So obviously the vehicle battery was down a little bit, so that seems to be running quite well. I was a little bit concerned at first when I connected that up because it seemed to be charging the battery for an age, but it seems to have settled itself off now. And as I say, the van start-stop's working fantastically, so obviously the battery was down a little bit. So hopefully that keeps the vehicle battery in good nick as well. Next we upgraded the charger because the one that was supplied just wasn't right for lithium. It wouldn't have performed efficiently, if at all very well. And then we moved on to fitting the lithium battery itself, and then we moved on to fitting a 3 kilowatt inverter. Now I appreciate some people want to do lithium without the inverter, and different people have different parts of this. Just before we move on from kind of what we've covered so far, it's worth calling out that I used the existing battery to battery charger that's installed in the van I got, because it had start stop in the eldest CV20 because it's an automatic, and I just used that one because I didn't see any point in spending on another one. If you don't have that, you would have to invest in a battery to battery charger. There's a number of different ones about. If you've gone with a Victron set, you can get a matching one for that one. I'll pop a link to that in the description as well, because it's handy if somebody hasn't got a battery to battery charger. So if you haven't got one of those, you would need those, because you can't use the split charge relay, because the lithiums can draw a phenomenal amount of power in, and you know, probably best case you'll blow a fuse. You know, worst case if you beef it up, you could burn your alternator out. So definitely need a B2B with lithium just to manage the charge. So now we're going to take a look at how we hang it all together, and we're going to start with the battery. First thing we did is get the battery installed, and then we connected the smart shunt, which is a Victron product, and what it basically does is it measures power going into or out of the battery, and it connects onto the negative terminal and then feeds on from there. So I've connected that up. Basically it feeds from the negative terminal of the lithium battery to the smart shunt battery end of it. It's marked up on the poles there, and then from the other end of the smart shunt that actually goes to the distribution block, or the bus bar that I've used there. And I've used a 300 amp capable bus bar there. And the reason for that, just before we move on into more detail, we'll just cover a little bit on wire sizing here as well, is the output of the lithium battery can be up to 250 amps continuous, or 500 amp surge. And the inverter, when feeding it through, if you were running it at full power, could draw up towards the top end of that, so you know, towards the 250 amp continuous load there. And so the smart shunt's capable of doing 500 amps, the bus bar's capable of doing 300 amps continuous and double that as a surge. And I've used the cabling between that. I've used a pair of 0 AWG, and we'll come on to that later, what AWG is all about. But it's pretty thick wires basically to cover that off. And the reason I've used a pair of them is just to make sure we're not warming up those cables when we're running things. Now, I'm not intending to run the inverter at high power, or certainly not for a long period of time. It's principally for coffee maker, microwave, that sort of thing. But I never want a problem if I needed to run something more powerful, so I wanted the job done right. So I've used a pair of cables on the negative, both into the smart shunt and out from the smart shunt to the distribution box. We'll come on to the inverter a little bit later. If you're not installing an inverter, you can obviously downsize the cabling quite significantly, but I would recommend making sure you've got, you know, maybe an AWG 3, maybe 4, just so that it can handle more than enough current without warming up, because heat's just inefficiency anyway through there. So moving on, so the next thing fitted is and this is in the kind of logical order rather than potentially the order you might fit it while you're going through. You'll notice when I actually fitted them, I was using some inline breakers. So got some kind of feedback on YouTube. One particularly drawn my attention was from Urban Van Life on some problems with some of the breakers not always being as safe as they need to be. Not saying that the ones I bought and where I bought them for were faulty, but I didn't want to take any chances. So what I've actually done there is I've put a 50 amp MIDI fuse in line, and then to a isolator switch, a rotary isolator, which you use for cutting the battery off. Now that gives me the ability then to isolate things. If I want to work on something, I can just turn it and switch it off rather than faff on having to pull fuses out. But it also gives me 50 amp protection for all of the kind of downstream circuits. Clearly I'm not going to run the inverter through that. We get to that a little bit later, how we connect that one up, but that principally feeds on to the various circuits and things, and also the charging feeds back through that one. The reason for 50 amp is it just makes sense. It's a 30 amp charger and I've got a 15 amp controller for the solar, so that could be up to 45 amps going in. Coming out would be typically a heck of a lot less than that, but that's the reason I got to 50 amps on there. And again, just making sure the cabling can handle well more than 50 amps, because you don't want the cable to be the weakest point there, because you don't want that getting warm and then potentially causing a fire. So let's keep moving along there. Worth noting as well, you'll notice there's a thicker, I'm just using the lines on the diagram there to represent the size of the wire. There's a thicker wire going into the fuse than there is coming out, for obvious reasons. That wire that feeds into that fuse holder, the short bit of length it has before it gets to that, actually needs to be able to take the full current for when the battery would cut out in the event of, you know, that coming disconnected or short circuiting. So that's the reason for that. The other side of the isolator then feeds into another bus bar. This one is, I think it's 150 amp rated, but we're not going to use anywhere near that. As you can see, it's coming in through a 50 amp fuse. That's the maximum we're going to be using there. And the reason for going for the smaller one is just space, really, because we're not actually going to be feeding any more than 50 amps through that, so it's more than adequately rated. The purpose of that is just to give us somewhere to connect up the the circuits that follow on from there. So it just makes it simpler and easier. So moving on to the next bit, we'll now get the connections back that feed back into the campervan. And depending on what campervan you've got, this is the ones I'm showing here around the kind of eldest CV20. The other eldest will be very similar, and the Compass campervans. But you might find your van, you know, quite different here. So when we go kind of down this leg, it's kind of what's fitted in your van. And what I've done there is I've fitted a breaker. Now I'm happy using the breaker there because upstream from there we've got a 50 amp fuse if anything doesn't work. And these breakers seem to be reasonably alright, the ones I chose for this. And I can cut the power just to that circuit then without having to switch the whole thing off if I need to do some work on it, for example, or if there was a problem with it. So the first one, the 30 amp breaker, goes to the main feed to the eldest distribution box, which is the box that has the main 12 volt fuses and also happens to have the breakers in for the mains as well. So that feeds onto that. And then I've got a little small 4-way fuse box, which I'm using 3 of the outputs for, and I've got 1 spare for the future. And one of them goes to the smart shunt with a 1 amp fuse in, because there's a 12 volt input to the smart shunt to power it up and make it work. That just goes in the right hand side terminal on the smart shunt. Just for reference, the second terminal on the smart shunt, you can either connect to the vehicle battery to do kind of monitoring of the voltage from that, or you can connect a temperature probe, and you can configure that in the Bluetooth app how you want that to behave. So that first one there through a 1 amp fuse, because again it's very small power needs to go there and we don't want the cable to be the weakest point. The next one, I've put a 10 amp fuse in which feeds to the alarm. Now I don't think the alarm is going to take 10 amps, and for whatever reason there was a 40 amp fuse feeding into it there, but I certainly don't think it would need that. It'd probably be fine with you know, a couple of amp or a 5 amp in, but I put a 10 amp in for now, and at some point I'll review that one. But just the reference to that was it did have a 40 amp fuse on originally feeding through the alarm, which alarmed me. The final one's a 15 amp feed. Now I confess I'm not quite sure what that one feeds through to. I have a sneaking suspicion it's either going to be to the fridge or to the step, but I just need to confirm that off. But it might go elsewhere. I'll have to come back to you on that one because I need to actually work it out. But that was in the original loom, so I've just reconnected that up neatly so it connects off that 15 amp fuse there. And that fuse box feeds back to that distribution panel, as does the breaker. So that's your kind of inputs and outputs. From the bus bar, the negative bus bar, you notice on the diagram there I've used blue for negative. It's just so that it stands out more. You'd normally use black for negative in DC circuits, but different people use different conventions. I think a lot of the negatives in the van are actually white, but I've used blue there just so it stands out on the diagram, not for any other reason. And the negatives connect back then to that bus bar there, the black one. That's the feeds into the van. Now let's add in, we needed to upgrade the charger from the standard charger, which wasn't lithium compatible, to a lithium compatible charger. So it added in the Blue Smart charger, and that connects up. The positive connects into a 40 amp breaker that then feeds into that positive bus bar, and the negative connects to the negative bus bar, the black one. And the reason that has a 40 amp breaker on is the current that flows out of the charger is 30 amps, so we need some headroom on there because the fuse is not to run at the exact rated current. It needs to run at it needs to be rated slightly higher than what we're actually going to put through it there. So that connects back through there, and again it allows me to isolate that if I need to switch it off at that end. There's a fuse at the charger end because we run it, it's kind of runs under the seat through some conduit between where it is kind of over this end to over that end where the battery is. So that actually allows us to make sure that it's protected at both ends by the fuse in the charger and the breaker there, which allows again isolation if you want to do any work on it, and it also gives an extra little bit of protection there. So that's the charger. The mains end of the charger connects and plugs into the original pointers you'd see in the video that we did on installing the charger as well. So just for reference, that's what happens with the mains end of the charger. So moving on now, the solar controller. So the van came with a solar as part of a kit. When we get to the kind of costings at the end, I've not covered the solar panel because I assumed it was already in. So just for reference on that, but I've covered the replacement controller, which I went for the Victron MPPT 7515 smart controller. Again, the reason for the smart one is you can keep an eye on things via Bluetooth from your phone or your computer. Basically that connects up to the solar panel, so you've got a couple of a positive and negative up to the solar panel, and then you've got a positive and negative that feed down. And in this case I put one of the inline breakers in. It's a 15 amp one, and again the reason for fitting that is not just for safety, because then I can cut the power feeding back up if I need to isolate it, but also so that you can switch it off if you need to do any work on it. Worth noting that just be careful with solar, because you should always keep it powered up from the leisure battery and have the leisure battery disconnected from it, because you've got a feed coming through when there's light outside or the sun's out. Even in daylight you can get quite a bit of kind of power feeding through there, so always make sure it's connected through, but it's more of a safety and the ability to isolate it there. So that's the solar controller, which feeds back through an inline breaker that I've got mounted again under the seat, as you'll see in that series there, and that's a 15 amp one inline there, because I'm not going to be running that controller flat out at 15 amps. So if you were, you'd probably put a 20 in, just for reference. We're now just going to cover off the battery maintainer. Now it's worth noting here, you'll see I've put the 12-volt vehicle battery with a dotted line, just an example. That was existing wiring that was connected up to the battery to battery converter that came with the van. And again, if you need to fit one of those, that's principally the connectivity there is you connect one half of it connects to your leisure battery, the other half to your vehicle battery, and there's often a feed to show when the actual engine's running, or D+, I think they call it, which basically then says okay to kind of charge back so it doesn't do anything strange. And I reused that, connected into the vehicle or starter battery as it's labelled up on there in German, and it feeds into the battery maintainer there, which is the Sterling Power Products device, and actually connected that to the charger connections just to save running wires all over the place, because it only produces up to 3 amps. It'll take from the leisure battery and run it to the starter battery to keep that topped up, but only if it's only over a certain power, so it doesn't drain your leisure battery down as well. But again, it seems to be doing a good job of keeping the vehicle battery nice and topped up, which should mean it lasts a while as well, and they're not cheap to replace obviously, so it's good to keep them in good condition. So finally, the last kind of piece of the puzzle of this setup is the inverter, and that connects via the negative into the bus bar, again with a pair of 0 AWG cables. Again, the nice thick cables here to make sure that we're not going to wire anything up when we're running the inverter at high power. And the positive of the inverter connects via another isolator, a rotary isolator again, and I've got two 125 amp MIDI fuses here feeding into it on two separate cables. And again, the reason for splitting it up is just to distribute the power there, so it's running through. I thought 125 amp was about right. Could have gone higher, but I'm not going to be running it above a couple of 100 amps, so that gives plenty of headroom there when it's running running anything kind of mains operated, which, as I say, typically is the coffee machine or the microwave or the hob or something like that, it's not going to be up in that high current amount, but can always upgrade them if need be, if that situation change. And it just gives a little bit of extra protection rather than relying on the battery management system to manage if there was a short circuit in the inverter. I think the things you've got to be quite careful with, there's some poorly made ones. This seems pretty good. That's the inverter connected, and then that has a remote to switch it on and off, or you can switch it on and off at the inverter. I covered off the kind of AC side of it and the automatic changeover relay to the sockets in the van in the inverter video, so I've not covered off the kind of main side of the inverter on this one. Hopefully that all makes sense anyway, but that's a kind of diagram of how I've got it connected up. And I've principally used either 0 AWG wire for the thick connections, which are the ones running from the battery to the inverter, the negative to the bus bar, the negative to the inverter, and the positives from the inverter to the isolator as well. The others are principally 3 AWG, but again, you probably get away with 4 AWG, but I just wanted to make sure, again, nothing was warming up. It does cost a little bit more the thicker you go, but actually you've set yourself up for the future. So I found this handy little chart that I've just got on the screen here that gives you a little bit of information on the kind of length of cable, kind of voltage drops and things heating up, and you know, how much current to flow through. It also, there's a handy size chart at the bottom there that gives you a rough idea. Obviously it's not totally to scale, so just kind of be careful if you're using it as a reference, but it gives you a rough relative size difference between the different sizes of wire, you know, starting off at 16 AWG. So the higher the number, the thinner the wire, and then going down, and you can see the thickness of the 0 AWG, you know, they're the thick cables on there, and all the way through to 4/0, which is the thickest one showing there. But that gives you a little bit of a view there, and I've just covered off the cables used in the setup throughout there. So that's the useful thing there. Just pause the video if you need this. I'll pop a PDF version of this presentation, a link to it as well, in the description in case that's useful later on, and hopefully that'll help anybody that's wanting to do something similar, just to kind of share a little bit of my experience on it. Anyway, let's have a look through now at the kit we used. So the first thing was a Roma 460 amp hour lithium battery with a 250 amp BMS, the Victron Energy Smart Shunt, the Victron Energy MPPT Smart Solar Charge Controller, the Blue Smart Charger, which is a 12 volt 30 amp one I went for. We got the pure sine wave inverter, the battery maintainer. We've got 2 MIDI fuses with 225 amp fuses in for the inverter, and we've got 1 MIDI fuse with 150 amp fuse in for the main feed through for the other electrics. 2 battery isolators, 1 for the inverter, 1 for the main feed. 1 40 amp circuit protector and 1 30 amp circuit protector, the 40 amp for the charger, 30 amp for the feed through, and a 15 amp inline circuit breaker for the solar. We had a negative bus bar, positive bus bar, small fuse box with a 1 amp, a 10 amp and a 15 amp fuse, and then various cables and terminals. So next week we've got the breakdown of the costs of all the equipment and the cost of the battery, and a cost benefit breakdown. So we'll catch you next week for that, and then following that, the final one is the so what video. And I hope you found that useful and informative. Thank you for watching. Catch you next time. Bye bye.